Hi scholars, my name is Ms. Perez and I am going to be your new teacher for this physics digital learning platform. I hope you and your families are all doing well during this time. Before we start, I just wanted to say a few words about myself. I am currently the physics and AP Physics teacher at Achievement First University Prep. And I am also very excited to go on this process with you guys. I am going to share my screen and show you the things that you should have on your desktop. So the only tabs that you should have open are Google Classroom. You can get the document that we're going to use for class from here, or you can also get it from the website Simplicity of Science, and then you should also have the document itself open. Great. Okay. Again, welcome to physics. So today we are going to go over Unit 5, Lesson 5. The things that you should have in front of you are your calculator, your notebook, a pen and pencil, and then again, the only tabs that you should have opened are the three that are outlined on the slide that I mentioned previously. Great. So today's aim is to identify the structure of a wave. It's more of a refresher than anything else. For most of you guys, this material is a review. We just decided to start here to make sure that we're on the same page and that we can remember everything that we covered before we went on this long break. And so now when we go on to new materials, and we have a solid foundation to build upon. The other thing is we're going to determine the speed of a wave using the wave equations. Again, as a refresher, just take the next 20 seconds to read through this vocab review. You shouldn't have the need to take notes. All of you should have these vocab words in your notebooks already. Great. Again, in the spirit of review, we are going to do this now. So I would like you to identify the following on the wave you see on the screen. The wavelength, the total number of wavelengths, the amplitude, the period, and the frequency. When I say go, in your notebooks, you're going to answer those following questions, and you're going to hit pause. Once you're ready, after no more than 2 minutes, hit pause, hit play again, so we can move on. Go. Great. Welcome back. So let's going to go over your answers and make sure that we're all on the same page. As I am annotating the screen, make sure to add anything to your notes or modify your answers if there is anything that differs. Okay, so first let's determine the wavelength. Looking at my graph here, starting from the origin, and we're going to go up, down, and back up again to where my wave starts repeating itself. So this distance here is 1 wavelength, and according to my scale, that is a distance of 2 meters. So I'm going to add that here. Awesome. Then the total number of wavelengths is how many waves I have on my graph. So here I have 1, and then go up and down again, and that's 2. So then there's a total of 2 wavelengths. My amplitude is the distance from the origin to the highest point of the maximum displacement. So that is going to be 4 meters in this case. The period is given to me here already. It just says, it's just a refresher that T stands for period. So that is 3 seconds. Again, that's a reminder, is the time it takes for 1 wave to go by. And then my frequency is related to my period by this inverse relationship of frequency is equal to 1 over period. And the frequency is how many cycles or how many waves go by in 1 second. So in this case here, it's going to be 1 over 3, which is my period, and then the unit for frequency is hertz. Awesome. Great. So in a minute, you're going to be doing a reading and going to be solving some practice problems. Before we go ahead to do that, I want to do 2 think alouds to model for you how to solve these problems, and then you're going to have the opportunity to be able to solve these on your own with the help of your teacher if needed. Okay, so take out, again, on your notebook, we're take any notes that you see on the screen as I go along. So for my first practice problem here, it says, what is the speed of a wave that has a frequency of 350 hertz and a 5-meter wavelength? So first, I'm going to annotate my question. So here I have the speed of a wave. So that's my V, that's what I'm trying to find. And then I'm given a frequency of 350 hertz. And then my wavelength is 5 meters, right? So remember, this symbol lambda represents wavelength. In the reading, you will see that the equation that connects all of these together is my speed is equal to the wavelength times the frequency of the wave. So again, the speed is what I'm trying to find. My frequency is given as 350 hertz. And my wavelength is 5 meters. Okay, I am writing everything on the side here to help me visualize all the information that has been given to us and to help organize what's happening. Right, so with my information, now I'm going to plug everything into my equation. So the speed here is equal to my wavelength, which was 5 meters. Right, and I am going to multiply that by my frequency of 350 hertz. And if I multiply those two in my calculator, I get 1,750. My units are meters per second because I'm dealing with speed here. And so that is the speed of this wave. Make sure you have all of this in your notes. Okay, so let's move on to the second problem now. So problem number 2 says the image below shows a wave traveling to the right. The amplitude of the wave is 0.5 and the wave goes 10 cycles every 2 seconds. What is the frequency of the wave and what is the speed of this wave? So first, let's annotate our problem. So here it's telling me that the amplitude of my wave is 0.5. And so I'm going to add that here to my graph. This distance here is 0.5 meters, this displacement. Oops. I'm going to erase that. Great. And then we're told that this wave undergoes 10 cycles every 2 seconds. So let's see what we can do with this information. So we're being asked to find the frequency. So frequency is equal to the number of cycles that go by every second. So in this case here, we're given that it has 10 cycles every 2 seconds. So then my total frequency is going to be 10 divided by 2, which is 5, and then my units are hertz. So that's the frequency of this wave. And then what's the speed of my wave? So we're trying to find speed. And based on the equation that we used in the previous slide and that you'll have in your reading, my speed is equal to wavelength times frequency. We have the frequency, we just found that, but the wavelength isn't given to us in the problem. But we can determine what it is by looking at our graph. So looking here, starting from my origin, I'm going to go down and back up to the place my wave starts repeating itself, which is this point here. So this distance is going to be my wavelength. In this case, it's 2 meters. So I am going to write here, wavelength is 2 meters. So now I can plug information into my equation. So the speed is going to equal to 2 meters times the wavelength, times the frequency, which we found to be 5 hertz. And if we multiply these two together, then we get that the speed of a wave is 10 meters per second. Okay. Again, I hope you wrote all this down in your notes. And if you have any questions, keep a note of those and ask your teacher in the chat once we are completed with the video. In a minute, you're going to start doing your reading. These are the key points that you should arrive at the end of the reading. The speed of the wave is dependent on the medium it travels through. And the speed of the wave can be determined by using these following equations, where the speed is equal to V, my period is equal to T, my frequency is equal to F, and the wavelength is equal to lambda. That's how you pronounce this. It's a Greek letter. Lambda. There's a B in there. Great. So now take the next 8 minutes to read and take notes in your science notebook and copy the CFS for solving wave problems in your notes. After that, for the remaining class time, move on to the practice problems that are following the reading. You can start now.